Electromagnetism is the branch of physics that deals with the study of electric and magnetic fields, their interactions, and their effects on matter. It is one of the four fundamental forces of nature, along with gravity, strong nuclear force, and weak nuclear force. Electromagnetism plays a vital role in our daily lives, as it is responsible for many phenomena such as electricity, magnetism, and light. The history of electromagnetism dates back to the ancient Greeks, who observed the natural phenomenon of static electricity. However, it was not until the 17th century that scientists began to investigate and understand the fundamental principles of electricity and magnetism. The first major breakthrough came in the early 1800s when Hans Christian Ørsted discovered that an electric current flowing through a wire created a magnetic field around it. This discovery laid the foundation for the development of electromagnetism as a field of study. In 1820, André-Marie Ampère showed that two parallel wires carrying electric currents exerted a force on each other. This was followed by Michael Faraday's discovery of electromagnetic induction in 1831, which demonstrated that a changing magnetic field could induce an electric current in a wire. James Clerk Maxwell's equations, developed in the 1860s, were a major breakthrough in the understanding of electromagnetism. Maxwell's equations describe the behavior of electric and magnetic fields and their interaction with charged particles. They also predicted the existence of electromagnetic waves, which led to the discovery of radio waves and the development of wireless communication. The applications of electromagnetism are numerous and far-reaching: electrical power generation, transmission, and distribution, telecommunications, computer technology, and medical imaging are just a few examples of areas where electromagnetism plays a critical role. Understanding electromagnetism is essential for developing new technologies and advancing our understanding of the physical world. Electromagnetism is generated by the motion of electric charges. When an electric charge is in motion, it creates a magnetic field around it. Similarly, when a magnetic field changes, it induces an electric field. This relationship between electric and magnetic fields is described by Maxwell's equations. The most common way to generate an electromagnet is to pass an electric current through a wire coiled around a magnetic material, such as iron. The electric current creates a magnetic field that strengthens the magnetic field of the material, creating a stronger electromagnet. This is the principle behind electric motors, generators, and transformers. Electromagnetism has numerous effects on matter. The most obvious effect is the attraction or repulsion between electric charges or magnetic poles. This effect is what allows magnets to attract or repel each other, and it is the force that holds electrons in orbit around the nucleus of an atom. Electromagnetism is also responsible for the behavior of electric currents. When a current flows through a wire, it creates a magnetic field around the wire. This effect is used in many technologies, such as electromagnets, electric motors, and transformers. One of the most important effects of electromagnetism is the production and propagation of electromagnetic waves, which include radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. These waves are produced when an electric charge oscillates or accelerates. Electromagnetic waves are used in many technologies, such as radio and television broadcasting, cell phone communication, radar, and medical imaging. In conclusion, electromagnetism is generated by the motion of electric charges and has numerous effects on matter. Its ability to create and propagate electromagnetic waves has revolutionized the way we communicate and understand the physical world. Electromagnetism is a fundamental force of nature that has several unique characteristics, including electromagnetic fields. Electromagnetism is associated with the presence of electric and magnetic fields, which are intertwined and interact with each other. These fields can exist independently of each other or can be produced by the motion of electric charges. Electric charges. Electromagnetism is intimately related to electric charges, which can be positive or negative. Like charges repel each other, while opposite charges attract each other. This is the basis of the electrostatic force. Magnetic poles. Electromagnetism is also related to magnetic poles. There are two magnetic poles, north and south, and like poles repel each other, while opposite poles attract each other. This is the basis of the magnetic force. Electromagnetic waves. Electromagnetism is capable of producing electromagnetic waves, which are a form of energy that travels through space at the speed of light. Electromagnetic waves have a wide range of frequencies and wavelengths, and they are responsible for many everyday phenomena, such as radio and TV broadcasting, cellular communication, and visible light. Quantum nature. Electromagnetism is a fundamental force of nature, and it is described by quantum mechanics. Quantum mechanics allows for the description of electromagnetic phenomena at the atomic and subatomic levels. Conservation laws. Electromagnetism obeys the conservation laws of energy, momentum, and electric charge. These laws are fundamental principles of physics, and they apply to all physical systems, including those governed by electromagnetism. In summary, electromagnetism is a fundamental force of nature that is intimately related to electric and magnetic fields, electric charges, magnetic poles, and the production of electromagnetic waves. It is described by quantum mechanics and obeys the conservation laws of energy, momentum, and electric charge. Electromagnetism has a wide range of advantages, applications, and uses that make it an essential part of modern technology and everyday life. Some of the most important advantages and applications of electromagnetism are: electrical power generation. Electromagnetism is the basis of electrical power generation. It is used to produce electricity in power plants, which is then distributed to homes and businesses through power grids. Electric motors and generators. Electromagnetism is used to produce the magnetic fields that power electric motors and generators. These devices are used in a wide range of applications, from powering machinery and appliances to providing backup power in emergency situations. Telecommunications. Electromagnetism is the basis of telecommunications. It is used to transmit and receive signals in cell phones, radios, TVs, and other communication devices. Medical imaging. Electromagnetism is used in medical imaging technologies such as X-rays, CT scans, and MRI machines. These technologies use electromagnetic waves to produce images of the body's internal structures. Electric lighting. Electromagnetism is used in electric lighting, including incandescent bulbs, fluorescent bulbs, and LED lights. Transportation. Electromagnetism is used in transportation technologies such as trains, subways, and maglev trains. These technologies use electromagnets to levitate and propel vehicles. Manufacturing. Electromagnetism is used in manufacturing to power machinery and equipment, such as welding machines, cutting tools, and metal detectors. Research and development. Electromagnetism is a vital tool in research and development. It is used in fields such as physics, chemistry, and materials science to study and manipulate materials and phenomena at the atomic and subatomic levels. In conclusion, the advantages and applications of electromagnetism are diverse and widespread. Its ability to produce and manipulate magnetic fields, generate electricity, and transmit information has revolutionized many aspects of modern life and technology. Electromagnetism is an essential part of our everyday lives, and its uses and applications continue to expand and evolve with advances in science and technology.